Okay, so I think we'll make a start. We seem to have more or less stabilised on numbers, but anyone who's still coming in, welcome along this evening. Thank you for coming to join us in this subject focus session. Today, we're going to be talking about engineering at Cambridge and at Homerton. And the session's going to be broken down into a few bits. To begin with, we're going to talk quite generally about applying to Cambridge and applying to Homerton. Then we're going to talk about engineering, and then we're going to have a Q&A. We're going to have three people talking today. So I'm Jo. I'm one of the admissions tutors, so one of the people that kind of looks after admissions to the college. And I'm going to give just a general overview about admissions and how things work here at Homerton. Then we've got Miles. Do you want to just introduce yourself, Miles?
Hello, everyone. Yeah, I'm Miles. I'm the Director of Studies for Engineering at Homerton.
And later on, we'll be joined by one of our students who's currently studying engineering. So we'll be able to answer any questions that you've got. Now, I find webinars very strange because I can't see anyone, but we should be able to get some questions coming through. If there's anything that comes up, any questions that you have that you want to ask, you should be able to see a button, I think, at the bottom of your screen that says Q&A, and you should be able to submit questions through that. And you might find that some of those are answered as we go along, and then we'll kind of talk through some of them at the end as well. So I've just put that over my presentation, but hopefully no one can see it, so it's okay. So we'll have that there ready for us as well. So I'm going to start by talking about applying to Cambridge University and applying to Homerton College. This is a lovely picture of Homerton. This is our old great hall that you can see in the middle here. These are offices and bedrooms. We've got the bar just over to the side. And actually, the college does look quite like this today. It's a beautiful sunny day here. We've got lots and lots of green space. And it's lovely to be able to go out and kind of wander around in that environment. In terms of applying to university, you've got lots of choices. Engineering is a great course, but why consider Cambridge? And I think there are a few points that we want to make here. The education that you get at Cambridge really is world class. If you look at various rankings and things, we provide a very good education. If you talk to the students here, they will tell you about the education. And Miles, as our Director of Studies, is one of the people who's in charge of overseeing that education here for engineering students at Homerton. It's broken down in a few different ways, that kind of how you learn, and I'll talk about that in a second. But it is a course that is a challenge. It asks a lot of you, but it gives you an awful lot of opportunities to get involved in different things and learn in different ways, but also participate in the research and the work that's going on in the department. Along with that kind of education side of things, and we do challenge people. We want people to really excel in their field. We offer a really supportive environment. So if you came to study at Cambridge, you came to study at Homerton, you might have Miles as what we call a Director of Studies, but we'd also have someone who was your tutor, who was there just to look after you and make sure that from a pastoral point of view, everything was going okay. And the support extends beyond just those kind of two people who are there. They're your people and you can go to them as you need to. But there's also a really supportive environment in the other people who work in college. But perhaps more importantly, in the peers and the peer group who you're working with, living with, and learning with. So if you come to one of the Cambridge colleges, they vary in size a lot. Homerton has about 180 people per year, and that's across a whole range of subjects. But what that means is you would come here and you would find people who are doing engineering, who are really keen and interested in talking about similar things to you. But you might also find people who are studying history and you share interests with them, or who are thinking about education or sustain, and all of these sort of threads will come together. And that peer group who are going through that experience with you, who are living with you and learning with you, are really, really valuable. There's also a really fulfilling student experience, and that is both academically. through the courses and the options within those courses that you choose, but also the broader student experience. So for example, within college, we have students who are involved in the Homerton Union of Students, who organise various events and things in college, but also take part in strategic meetings about how the college is run and really have an input into how things happen. There are other things going on in college. We've got societies that exist in college. So we might have the college choir, for example. They rehearse every week and they sing at evensong. They sing at lots of the big formal hall events. There's a drama society. We've got a dance studio. We've got sports fields. And so there's lots of stuff that can happen in college. One of my favourites is the coffee society, which exists, and you can go and drink coffee 3 mornings a week, free coffee and a chat. But isn't that great for just getting people together and getting people talking and building those bridges across year groups as well within college? Outside of our college, there's also the rest of the university. And so you might find that you're particularly interested in something that doesn't exist within college, and either you can start it or you can look more broadly and join a society or a club that brings together people from all the different colleges across the university to do whatever activity that is. And that's really nice because it also means that you get to understand different people's experiences and work with people and learn from people who are coming from all those different colleges, which is a really lovely thing. So when our students join us later, we might see what they're interested in. A couple of the things I've learned about recently, just through talking with students, was fencing, which is quite a fun thing to join in with. You can learn that from scratch, or if you're good, you can kind of keep going. There's loads of other sports clubs. Water polo has come up recently as well. But there's also things that aren't based around sports. So there's various poetry societies, for example, or drama, and music at a whole range of different levels that you can get involved with. So hopefully that gives you just a little bit of an idea about what Cambridge can offer. This quote that you've got in the green box here is important as well, thinking about what happens after your degree. And so we've got really, really good moving on into graduate roles that happen afterwards. And that's a whole range of different things, dependent on your subject, but also a range within your subject, depending on what you want to do. And that's something, again, that your Director of Studies and your tutor and the Career Service can all support with. It's quite a tricky thing, I think, when you're thinking about Cambridge, to understand what the difference is. Why do we have colleges and a university, and what's going on and how do they work together? And so I just wanted to talk a little bit about that. So the university determines the content of all the courses. If you're coming to study engineering, whichever college you're at, you will have the same engineering course and the same examinations at the end of that. The large teaching, the lectures and the practical classes will be arranged by the university. And so you might be working with people from different colleges, sitting with people from different colleges. And so that's a lovely way to bring you together. They also award the degrees. We have quite soon, actually, now coming up, our degree ceremony, which happens at Senate House, and you go through, and at the end the university awards those degrees. The colleges have a slightly different role. So we look after admission of undergraduate students. So when you apply, you have two choices. You can either apply to a specific college, or you can make what's called an open application, which is an application where you don't choose a college and there's a computer program somewhere that assigns you to a college. And then it's just like you applied there to begin with. So that's another option for you. If you apply to Cambridge, you'll apply to a college. They will look at your applications. If you get invited to interview, it would be them that interviews you and then makes those decisions. Once you're into a college, the college provides your academic and pastoral care. That's your Director of Studies and your tutor that I've mentioned already. But it's also the place that you'll live. So they will often provide your accommodation. And we've got accommodation for all of our first years, tend to live together in what we call West House. And you're on a corridor with a group of people. And some of those will be from your subject and some won't. It's all done so that you have kind of both of those there. And those will be separate bedrooms that everyone has, but shared kitchen facilities. So there's a nice chance to get to know people. We also have the dining hall, which provides 3 meals a day. If you choose, you can buy your meals there, or you can prepare your own in your kitchens. And as it says, kind of recreation, that's a coverall. So it gives us, college gives us football teams and rowing and drama societies and all of these things, but also unplanned, just socialization with friends. We've got a nice bit of green space actually just outside my window here, where there's lots of students who are all sat together on the grass revising. And although that may not feel quite like recreation, it does mean that they're there and they're working together and they have that socialization in there as well. Colleges, and for Engineering Miles in particular, also organises the small group teaching or the supervision, which is where we have normally one academic with 2 or 3 students working through the ideas that have been covered in the lectures. And that's a really great opportunity to think much more deeply, much more critically about the material that has been covered with you, and check your understanding and really push your understanding. And then we also have facilities for academic studies. So we've got a library and some really excellent librarians who support there, along with various other study spaces within the college. In terms of who Homerton are, there's some good pictures here, I think, that represent us quite well. We are one of the largest and most diverse college communities. So we take students in all subjects, which is great because it means you get to meet someone who's studying vet med and someone who's studying theology, and sit next to someone who's studying maths, and everyone comes together to give us a really diverse community. We combine the old and the new, and this seems like a sort of slightly strange thing to say, but it's true both in terms of the buildings that we've got. So you've got pictures here of the Great Hall. Here's a nice old building, and here's our new hall that we tend to eat in now, which has been built quite recently, very sustainable in the way that it's been built. So we've got that really physical representation of the old and the new, but I think more importantly, we have all of the traditions of Cambridge University, but we're also really kind of forwards thinking about our teaching and the teaching and learning that goes on in college. We've got lots of people who are involved in education, involved in research, and involved in learning within their subjects as well. So real experts at making sure that the undergraduate students get the best experience they can. The last 2 points here, we're committed to making a positive impact on the world. And the point about change makers kind of go together, because one of the things that Simon, and we've got Simon on the next slide, there's Simon, he's our head of our college, principal of Homerton. One of the things that he says really often, and it is a real part of who we are here, is that it's not enough just to get a great degree. It's got to be doing what you can to get a great degree, and then thinking about how you can go out and make a positive impact on the world in whatever way is right for you. There's no one way to do that. But one of the programs that we have in college to support you in doing that is called Change Makers, which is a co-curricular program. It runs alongside people's degrees that you can opt into in whatever way works for you. And it's all about thinking about, well, how can I become a leader out in the world? How can I use the skills, the academic skills that I'm gaining? How can I use other skills? How can I gain other skills? And we have people who come in and talk about a whole range of things that will be useful when you go on beyond Homerton as well. We've got some history of the college. This isn't all history, so it's not a great title for this slide, but it is important, I think, that we are perhaps in some ways the newest college in Cambridge, but actually Homerton as an educational institution has existed for a really, really long time. It was founded 1768 in London, and then moved over here a while ago. In terms of where we are, as I've said already, the grounds are really beautiful. We've got really great facilities, and thought I had some pictures of them, but I don't. But the gym, the sports ground, the library, the cafe that we've got is adjoining the new hall. And then the student union is a great way for students to be represented, but also to support each other. And so they've got space within the college and a voice within the college. We also have, which is quite an important thing, some of the cheapest accommodation in Cambridge, and we've got loads of ensuite rooms, and that's often really important to people as well. There is various financial supports available, and I know that it can feel like the transition to university can be really big decision, a big change financially. But there are various grants and scholarships that some people may be eligible for. And there are things like internship grants. So I've got students at the moment who are in their second or third year who this summer are going to be undertaking internships where they're going to be doing research in areas that they've been studying during this year, and the college supports with that in terms of accommodation or grants. And there's also a hardship fund, so that if there is really unexpected significant hardship, the college can support there as well. There's lots of information on financial support available on the university website as well, and I'd encourage you, if that is something that is a kind of consideration or a concern for you, have a look there, because there's lots of information. In terms of, you come to this talk, you think, yeah, that sounds quite good. We'll listen to Miles talking about engineering. We'll all think engineering. Oh, yes. And if you want to then apply to college, what happens is, firstly, you have to choose your course, and you generally choose a number of courses, apply through UCAS. And if you're applying to Cambridge, you have to then pick either a college or an open application. If you're looking at colleges and
I don't know if it's just me, Joe, but I can't hear you now. You've gone silent.
how odd.
Oh, now you're back.
Oh, brilliant. Thank you, Miles.
Right.
Where did I get up to? I'll start again just on the application process. So if you want to apply to Cambridge, choose your course, and then pick a college or an open application, depending on what feels right to you. And I was just saying, there are the university open days coming up. If you have a chance to come and visit and have a look around, I'd really encourage you to. Lots of the colleges will be open. We'll have talks going on in college, I think 10 o'clock in the morning, and there'll be loads of students around to be able to show you around college and just get a feel for it. Then you have to think about admissions tests, fill in your UCAS application. That does feel like it might be in the wrong order, but you do need to do it in this order because sometimes the deadlines are slightly offset. It does say there that the UCAS deadline, usually the 15th of October, you will find that if you're applying through your school, they will probably set an earlier deadline. Please obey their deadline. That is because they have lots of jobs to do with it after you have submitted that. So make sure that you are giving them time to do that as well. We will then ask you to provide various additional information, but that will all be communicated to you later on. And you would do your admissions assessments. And then we hold interviews generally in early December. And Miles will talk a little bit more about what those look like in engineering. And then decisions come out in January. It is competitive. We do get more applications, considerably more applications than we have places. But what I would say is that if you are interested in applying to Cambridge, apply, because if you don't apply, you definitely don't have a chance of getting in. Whereas if you do, you're giving yourself that opportunity. I'm going to stop there, Miles, if that's okay, and hand over to you. And hopefully, I need to stop sharing. There, I'm on the wrong screen. Stop sharing. That should be ready for you.
Good. All right. Thank you very much. I will open up. Allow. There we go. Right. Can you see that, Joe?
Yes, I can. Thank you.
All right. Thanks very much. Right, everyone, just to let you know, just in case I don't seem the world's most enthusiastic individual, I'm quite ill today. So normally I'm not this lethargic or somewhat lacking in inspiring motivation. But so cut me a bit of slack. But we'll plough through and get you onto the Q&A, which I'm sure a lot of you are quite keen to get involved with. So, uh, like like I said earlier, my name's Miles. I'm the director of studies at Homerton. So I'm your principal academic contact in the college, and really are somewhat of a liaison and overseer of your education in the department. So, although I will in all likelihood lecture you, and I will most certainly supervise you in small group teaching. We call them supervisions. Other people might call them tutorials. Um, your majority of in your sort of contact hours are in the department. Um, However, as a director of studies at a college, it's my responsibility to choose who the college selects. So I run the sort of admissions process for engineering. I actually run it for the department as well. I'm the director of admissions there. So if you come to the open day in July, you'll see me giving a talk or two. Um, Once you've arrived at Homerton, I'm the one that's responsible for making sure that you know the rules of the game and that we play it most effectively. I'm quite a competitive individual, so I like that Homerton is good at engineering. It has not always been the case, but in the last 5 years, we have become one of the most academically achieving colleges of all. We get above several percent above the average for the university-wide engineering cohort in terms of those that get good honours. So that's 2-1 and a first, and we have a slightly higher than average number of firsts than any other college. We top Tripos, so we got the highest mark in the year for several years running, actually, until last year. Unfortunately, we were pipped at the post by another college that I won't name, and that sort of spans across many different specializations. We seem to do remarkably well in mechanical engineering. Um, why that is, I don't know. But it may be because I'm a mechanical engineer and I managed to convince you all to commit to it. I don't know, but we'll talk about specializations later. So let's have a little think about engineering. One of my primary objectives really at this stage in your consideration of Cambridge is to make sure that Cambridge is the right place for you and you make the right decision. But not only that, but you've got to think about actually what is engineering, and is an engineering degree right for you rather than an apprenticeship, for example, or natural sciences, or vice versa. So the way of thinking about engineering in comparison to science, and I get a lot of students asking me, I don't know if I want to do physics or engineering, and that I'm not surprised by that, and you shouldn't be worried if that's the case. When I was 17, it's near impossible to know exactly what you want to do unless you've experienced something, and the chances of you experiencing engineering at 17 are pretty slim. So the way of thinking about this is if you like physics and you like maths, you like being creative with mathematics, and you want to make new things and solve problems, engineering's for you. If you like discovering things that already exist and trying to create the theories that justify what we see in the real world, science is probably a little bit more for you. So the engineers are the ones that really solve the problems. Scientists just tell us things that already exist. That sounds a bit mean, but I don't mean it in a mean way. So, why study engineering at Cambridge? Cambridge is rather unique in its approach to engineering. So we are the largest department in the university and the largest cohort of undergraduates as well. We're only really rivaled, and it's very, very close, with the natural sciences, but they're distributed across many different departments. So we combine all of our divisions: aerospace, bioengineering, civil, electrical, information, manufacturing, mechanical. We did have chemical. They've split off now and formed their own department. So if you want to do chemical engineering, you've got to apply for chemical engineering, not for engineering. They're a different tripos now. That's only been the case for 2 years. So we encompass all of those specializations, and you can choose one of those specializations. You can actually choose modules from all of those specializations, but it is near impossible for you not to end up specializing in one thing over the other. We'll talk about that later on. And those kind of specializations really, it's like I said, it's near impossible to know what you really want to do at your age at this point. So the unique thing about Cambridge is that we allow you to experience all of those different specializations before you've really got to commit. So it's very much a multidisciplinary course. So you'll get a taster of some of the specialization areas. We give you some module sort of example lectures in second year before you have to commit and decide what modules you're going to take for third year. By the time you get to your second year, you've had a decent dose of the various specialisms that we offer in the department. So you should be able to make an informed decision rather than winging it on what you may have read in a magazine or what your parents do. So, give you some ideas. Aerospace and aerothermal engineering was the most popular specialization. It has gone down in popularity recently because of the emergence, or the growth rather, of information engineering, so computer engineering. But it's still very, very popular and was the most popular when I was a student. Got some interesting individuals here. Top left there, that's Jenny Sidney. We were peers together at Jesus College, but she is now an astronaut. So she went through the right door, I think, and I didn't. But there we go. Bottom left, we've got a novel design of plane that was being developed in the department by actually a group of students, albeit guided by a PI, a principal investigator professor. And then that's the Markham Wind Tunnel in the top right. And that's someone testing some ski gear in the wind tunnel. I don't recommend you just climb in the wind tunnel without authority, but no matter how many times I say that, I still find students trying to climb in the wind tunnel and turn it on. It's next to my office. Electrical. So this is now the most popular, although it's going up and down aerospace and in information year to year. Bottom right, that's McLaren, for which a research group developed the suspension, adaptive suspension for that. We are looking at trying to assist in robotics for those that have had medical procedures that then necessitate them having assistive mobility. We've got virtual keyboards, all kinds of things being developed in the department. Civil, structural, environmental engineering. We've got students that have gone off to earthquake hit regions and looked at trying to improve dampening of buildings, so earthquake resistance. You get quite a lot of site experience through that, all the way down to actually looking at developing new types of concrete or new ways of manufacturing concrete that dramatically reduce the carbon footprint. Mechanical engineering, bioengineering. On the right there, that's Port Talbot. So that's a big steel works in the UK. So we send students down there for a little visit. They're always disappointed that there aren't dwarves with hammers bashing things away. It's not Lord of the Rings. They are just big machines forging and rolling things. On the left, superconductor, type 2 superconductor levitating. If you want to call it the fancy thing, it's called quantum levitation. So As I said, unique structure to Cambridge. That flexibility is good for you to get a bit of experience so you're not making a mistake, you're not committing early on to specialization where you might regret it later on. I mean, from my perspective, when I started, I said unequivocally, I want to be a civil engineer. And at the end of my second year, I said absolutely without a shadow of a doubt, I never want to be a civil engineer. And I moved into nuclear engineering, which is really mechanical engineering. And I develop nuclear reactors. Is my principal role. So very fortunate that you get that flexibility because it avoids that risk. And regardless of if you know exactly what you want to do, the benefit, the flexibility that Cambridge offers is it makes you a multidisciplinary engineer. It allows you to better collaborate with engineers from other areas, and that is quite a skill that is attractive to prospective employers. So our graduates have very little difficulty acquiring jobs, and one of the reasons is not only their academic excellence and their incredible work ethic, but the sort of engineers we produce that are multidisciplinary, have a good theoretical understanding, but have the practical skills necessary to excel in a range of engineering fields. Course structure, first year, integrated engineering course. You're all in it together. You got no choice what you do. We have a variety of modules to get you those experiences of specialization. That continues into the second year. Then we transition you into the third year by getting you some experience and some examples of some of the modules that you can do, which are built upon that you study in the first and second year. And then you can choose your specialization in the third. Some of our students go over to manufacturing engineering. It's about 30 to 40 each year. So that's a bit more of the business side of engineering. So you do a bit of management, bit of engineering business, and as you would guess, a little bit more on manufacturing rather than the more theoretical aspects of the specializations that I showed you previous. Then fourth year, you can continue with your specialization. There are actually a lot of modules that you can take in fourth year or take in third year. Some require you to have done a previous module in third year for you to do it in fourth year. But as a DOS, I'm the individual that helps to guide you through that. And then you graduate, and you graduate at Cambridge. Again, Cambridge being unique because that seems to be what we like doing, is you graduate with really 2 degrees. You graduate with a BA, which is a Bachelor of Arts, which seems strange as an engineer, but that's a Cambridge antiquated process. And you get your MEng, which is what you would expect at other universities. So lucky you, 2 degrees. Lots of modules that you can do in third and fourth year. I'm not going to go through these because I'll probably leave you unconscious. Let's just say there's about 110 to choose from. You can choose 18 modules, 10 in third year, 8 in fourth year. About half your modules are usually from a specific area to qualify in that engineering area. Chances are, if you take things from all kinds of different places, normally you can actually specialize as a mechanical engineer. Seems to be one that prevails. It is very hard for you not to end up with specialization, but if you do miss a specialization, you end up graduating in general engineering. Okay, still accredited. There's no sort of issues with that. It's just not accredited by a specific institute like Institute for Mechanical Engineers or the Institute for Civil Engineers. Typical week, for a first year engineer, slightly different for a second, a third, and a fourth, but you are jam packed in the mornings. So labs and lectures. That's every morning. You get a bit of resuscitation, typically on a Wednesday. You'll have an hour or so free, sometimes on a Thursday as well. And then you'll also have things like drawing classes or engineering workshops, which can go on into the afternoons as well. But most of the afternoons are self-study and supervision. So those tutorial sessions with specialists like me. So as an engineer, you have the highest contact hours of any student at the university. We have our work cut out, but We deserve all we get at the end of it. Right, so teaching, you got lectures, classes, private study. Most of your time is actually spent private studying. So it is quite a transition from your time at school. And it's my responsibility to make sure that we transition you into being able to do that. There's not this magical university fairy that when you turn up goes ping and you can suddenly be independent. It is a transition and it takes a bit of effort to acclimatize to that. And you've got to have a lot of self-discipline and you've got to enjoy and be able to commit to self-study. If you think you can kind of wing your A levels, and you'll do well, and some of you can do that with very little revision, and then you can carry that on at Cambridge, there is no chance of that. You have to put the effort in, and the more you work, the better you will do. So normally expect about 40 to 45 hours per week on your studies, and that's the largest of any course at Cambridge. And Cambridge is the largest of any university in the UK. Labs, all kinds of labs that we offer, right from cryogenic testing all the way to the basic tensile tests. Grab a piece of metal, put it apart, see what happens, figure out what material it is, how can we change that, and then what is the relevance of that when we're designing engineering systems. Then you've got your supervisions. So they're those small teaching tutorials. So you normally have, I say 2 to 3 per week. I mean, now it's more like 3, and some weeks you may even get 4. At Homerton, we normally have 3 students per supervision group. We have a particular approach at Homerton because we're quite a cohort. We're quite a strong community, and we encourage each other and we work together a lot more than perhaps at other colleges. And it's proven that it works because of how successful Homerton has been academically, and the students are very happy with the way that Homerton approaches that, because you make very strong friends. There isn't that competition really in the college. We compete with other colleges, so you have a real group mentality of all your peers helping you and you helping them, because there's always going to be something that you can't do so well that your pal can, and vice versa. And so when you've got that relationship where you help one another, it really does have a significant impact. And I'm very, very proud of the Homertonian engineers for really embracing that approach to collaborative learning. So interesting things you get to do on the course. First, second year projects, you got Lego that you get to play with in the first 2 weeks. Lego Mindstorms. Some of you may have heard of Lego Mindstorms before. Make something with Lego that is, quite remarkably advanced relative to what your usual experiences are with Lego. So we've had people make cranes, AI run cranes that automatically detect and pick up bits of Lego and put them together, and or self-driving vehicles, all kinds of things. It's remarkable what people can make with Lego. Then you get structural design project. We get to build a bridge and test it. And that's quite a good competition. And not that I'm trying to plug Homerton too much, but it's not unusual for Homerton to get first, second, and third place, which seems to annoy a lot of the other colleges, but it makes me happy. So that's all that matters. We've got the integrated design project where you have a minesweeper, a robot that is supposed to effectively detect mines. Obviously, we don't offer you real mines because that would be dangerous. But again, Homerton tends to dominate those competitions. Third and fourth year projects, similar to the first and second year, get to do those group works. It depends on what module choices you choose. So you can go and do some site work as part of a project, for example, or field work. You get to do some languages, get to learn a language as part of engineering. That contributes to your module credits. So a lot of students fancy learning Japanese. Some people want to continue the language that they already have a bit of experience in, which is more commonly Spanish or French. And some people want to learn an entire new language from scratch. And then in fourth year, that's when you get to do your major individual projects, so your dissertation. And you can pick from hundreds of projects that are available in all the different specializations, and you can even suggest some yourself by talking to the respective professors in those research fields. Gap years, industrial experience. Actually, to graduate, you've got to have industrial experience. It's part of the accreditation requirements of the course. And you need to do 6 weeks of certified industrial experience. Um, don't worry at all about that. It's relatively straightforward for students to get internships over the summers when they normally do it, and that will fulfill that requirement. And if you are struggling with that, which is incredibly rare, we have an industrial coordinator that finds people placements where necessary. Okay, she's full time. Right. So I've mentioned the word accreditation quite a lot. Some of you might not necessarily really know what that means or how relevant it is, but it's remarkably important for degrees that they are accredited, because it means that when you graduate, you can go and become a member of that institution, and then you can get chartered once you've got some industrial experience. Once you've worked for a couple of years, you can apply for chartership, which means that really then you are an official engineer. It gives you that legitimacy. In Germany, for example, if you want to be called an engineer, you have to be chartered. It is illegal to call yourself an engineer if you are not chartered. In the UK, engineering is not a protected profession like that. So you can call yourself a plumbing engineer or electric engineer when actually you're not a chartered engineer. Okay, so your accreditation helps contribute to that, and I guide you through that as a director of studies. Now let's talk a little bit more about Homerton. So we talked about the university-based teaching, your lectures, seminars, classes, your exams are written and hosted by the department, as are your labs. College-based teaching is that supervision. In addition to that supervision, engineering is quite unique. We offer a bit more bespoke coaching in terms of your career, where you're looking, what kind of placements might you want to experience. We have our own connections with particular companies where we like to encourage students to apply. For example, if you want to be a structural engineer, then actually there is a company just outside of Cambridge where I've sent students. The company mainly specializes in steel and glass buildings, but the college can offer you accommodation during the time of your internship, so it saves you a bit of money, and of course the internship will pay you as well, so you get a bit of experience with structural there. But we've had students go all over the country and abroad for their industry experience. We have career and study support. So I run workshops. I run workshops on revision, how to revise, how to approach a Cambridge exam, how to collaborate and work as groups. In your first week, we have our own, effectively a bridging program, and I take you away for about 2 days, and we spend that time together learning about the engineering course and the best approaches. And we are an academic institution, so we make evidence-based decisions. So everything that I say to you about approaches to take and our strategies for you to do well is based on research. Okay, I'm very data driven. If you're an engineer, normally you are quite data driven, and I will show you the data to justify approaches that make Homerton such an outstanding college. And we're getting quite noted for our academic successes, and I think eventually everyone else is going to catch up a little bit. So we've got to keep improving. So I'm your academic guidance. I'm the one that supports you there. I'm the one that sources your supervisors. I decide who teaches you, how often they may teach you, make sure that they give you revision sessions, things like this. And then you have a personal tutor who is for pastoral welfare and well-being concerns that you may have at any point. We all have little hiccups, and they're there to support you during those. Engineers have a particular there's certain aspects of the Changemakers program, which Joe mentioned earlier, that engineers are quite attracted to, and that tends to be the mentoring aspects. So I've worked quite hard with change makers to try and encourage recruitment of engineering mentors, people that have experience in industry that can give you their sort of finger on the pulse and identify the skills gaps and what companies, particular companies, are looking for in engineers, and help to steer you in your kind of strategy to acquiring a job. So they can steer you in what modules you might want to choose, what industrial placements you might want. They can help you with your CV, help you write cover letters, and just give you general guidance on what the engineering environment is looking like at the moment. They're brilliant networking opportunities, and I work hard to make sure that we have seminars and events that you can come to for those sort of things. I'm actually on sabbatical this year, so I'm away. So I must put my hands up and say I haven't had many networking opportunities this year, but we're going to get to that soon. Homerton Library is pretty good. I make sure that it's stocked with all the engineering books you need. I don't like students working in their rooms. I don't think it's a healthy thing. I think you should work in the library or the engineering department, which is huge, and there is always a space for you to work either collaboratively or by yourself. And I make sure that you know where those are and that you can use them and that you're happy. You've also got student guides as well. There's a tremendous number of sort of willing students to support you in the department, but also at Homerton, we've got our own engineering society. And if you're struggling or need some help, one of the individuals in the later years, second, third, or fourth year, will more than happily jump and assist you, and you'll get to know them very well. So, I tend to encourage peer-to-peer support. So a lot of the kind of workshops or programs like that work best when they have a peer-to-peer support mechanism. So they give guidance on studying, as do I, time management. They talk about their experiences, what they wish they'd have known as second or third year. Will say, I wish I knew this at the start of first year. And well, fortunately, then you know it. They'll give you guidance on exams. They'll give you that reassurance that, yeah, I was as worried as you, but it works out all right. And hearing that from someone that's just experienced it can really be quite a valuable experience. I can see the Q&As coming in. We'll jump on the Q&A shortly, and I'll start answering your questions. If you've got any questions, yeah, fire away in the Q&A. That's fine. A big part of engineering at Homerton is, that peer-to-peer support needs to have a healthy community. We've all got to sort of collaborate. We've all got to respect each other. And at the very least, I expect everyone to be cordial with one another. No matter how much you may disagree with someone's opinions on something, we are all cordial. This is a professional environment and we respect one another. And actually, the engineers, we're pretty pragmatic people. So it's very rare that we have any conflicts in the engineering community. So far from it, actually, we often tend to have curry nights. So I normally organize at least one curry night a year, and the engineers themselves host a lot of other things like swaps. They'll go to another college for dinner, then they'll host a college. They'll go and do events. We've had engineers start a band, a music band. We have a really strong representation on the Formula student, like the Formula One for students. That is got a significant number of Homertonians in it. I think about 5 in the principal team. They've created societies, all kinds of, if you can think of it, it probably exists. If it doesn't exist, then you can create it, and I'll help you develop that society. We do lots of competitions to help you with your presentation skills and oratory skills. So you can enter a competition to talk about any kind of subject you want to the other engineers. It tends to be a good laugh, tends to be quite comedic. Often we do that before the annual engineering dinner, and we have all a good laugh with some of the bizarre designs or concepts that engineers come up with. Some have been a little bit dangerous. When someone tried to create a flamethrower, a wrist-attached flamethrower, I really did not recommend that continued on, and I don't recommend that you do that either. But normally I keep a better eye on things. That's the Great Hall in the bottom right of Homerton. Top right is the Holly Festival. The engineers went to the Holly Festival and decided to throw paint at each other. And then there's some punting at the bottom left. I normally organise for all the engineers in the older years to take the younger years punting once they've finished their exams. They pick you up from the engineering department. It's next to the river. You get out of your exams. The older years have got the boats ready for you. You jump on the boat and you have a celebration. You don't need to pay for that. I pay. Well, I don't pay for that. The college pays for it. There we go. So, oh yeah, we have a boat as well. So the engineers joined a boat and rowed the bumps, which is a rowing competition. Should you wish to row? Cardboard boat race. That's always been a popular one. That may be my fault. That boat on the right there was developed when I was at Jesus. That was our Jesus boat. We wanted to make the most elaborate cardboard boat ever, so we made a dragon. That's black and red for Jesus, where I studied. But actually, the Homerton engineers have quite dominated in recent years. The bottom left is one of the Homerton teams. They make a tank of a boat, and they have always enjoyed it. And everyone crowds the side of the river and watches these boats slowly sink. Griffins is the Homerton Sports. Lots of engineers get involved with that. I won't talk about that too much because Joe talked about it. We got a gym. You see a lot of engineers in gym. Basically, engineers are everywhere because there's so many of you. We're the largest engineering college. Trinity and Homerton fluctuate. Who is the largest engineering college depends on the application numbers really a little bit and the quality of the applications. But we are the largest engineering college overall. So it's almost unavoidable to escape, almost unavoidable meeting engineers at Homerton. Right. So whether you like it or not, if you come to Homerton, you're an engineer, you're a Homertonian engineer for life. So these are some of our engineers that graduated about 6 years ago. So that's the hood that you graduate in as an engineer. And we often have engineers coming back. I speak to alumni quite often, and they say, hey, just to give you an update, I'm now a traffic controller. I thought, well, it's not necessarily engineering, but congratulations. All kinds of things. And I write references to this day for students that have graduated years ago. Right. So how are you going to get in? You can find a lot of this information online. So I'm going to run through this very, very quickly and focus on some key important things like interviews. So choose your course, choose your college, Homerton. Check your admissions assessment arrangements. That's actually just been open. If you're eligible for a bursary for the engineering admission, the ESAT engineering science admissions test, that's just about to open. I think on the 5th of June, that opens for you to be able to submit for a bursary. You have to have registered by September, and information on that will be added to the UAT, as in, like, if you Google ESAT, you'll find the web page, and you can register there. One of the key benefits of applying to Cambridge for engineering is often people apply to Imperial as their second choice, and if you apply to Cambridge and Imperial, you only have to do one admissions test because Imperial have agreed to use the ESAT, the same test as the engineers. I help write the test. I'm the one that oversees the test. And I'm very, very pleased that Imperial have joined, and it has certainly helped us, help students with the ease of applying to both, rather than applying to Oxford, where then you've got to do the PAT test, which is another test that you have to do. Right. Okay, let's plow through. I'm looking for academic ability, principally. Okay, I want to see that you have thought about applying to engineering, that you understand the course, and that you have are pretty confident that you want to be creative with maths. One of the key indicators of success in the course is ability in mathematics. So that is one of the key things that we assess in the ESAT, and one of the key things that we assess at interview. All right, so that's quite important. So really, when you're applying, you're going to apply with 3 or 4 STEM subjects. We expect you to get the entry meet the entry requirements in terms of your grades. If your school offers further maths, you should absolutely take it. The more maths you can do, the better. If you can't do further maths because your school doesn't offer it, you won't be disadvantaged in your application, but you should try and learn further maths independently. Okay, get as much experience in maths because it will help you. It will certainly help you with the ESAT, for example. So, ESAT. The dates have changed. These are dated from last year, but they're approximately the same dates this year. You've got to register for the ESAT by sort of normally mid-September. You take the test in the first sitting for Cambridge. If you just apply to Imperial, you take it in a different sitting. Sitting is in October. Okay, so actually you end up taking your test right when your UCAS deadline is for when you submit your university choices. You take maths, physics, and maths 2. You don't get a choice if you apply to engineering. If you apply for natural sciences, you get a choice. Engineering, you don't. You just take maths, physics, and maths 2. Best approach to getting ready for it is keep studying at school. I mean, do your schoolwork. That's the best preparation you can have for the ESAT. And there's free practice materials on the ESAT website. I would recommend you probably do one or two under time conditions. You don't really need to do any more than that. It's all based on your schoolwork. It's largely GCSE with a little hint of AS level there. Okay, then you got the interviews. So based on your ESAT and your paper application, which is your A-level predicted grades, and your ESAT, we choose to either interview you or not. And at interview, our principal objective is, again, identify your academic ability. So some do online, some do in person in interviews, and colleges advertise whether or not they're doing in person or online. And most of the interview is dominated by technical problems that I, as an interviewer, and I interview all students, engineering applicants, apart from when I'm on sabbatical. I interview all Cambridge applicants to Homerton, and I'm the one that's going to ask you, for example, the mechanics question. All right. So the most important preparation for interview is I want to see that you can think for yourselves. So just get a bit of practice at tackling more conceptual problems, because the problems that I'll ask you in interview are slightly different to what you would expect in school. And actually the best guide to get a bit of understanding of what I'm going to be asking is go, I want to study engineering. Just Google, I want to study engineering. And you get a website, I-want-to-study-engineering.org.uk. And that's got packed full of questions, example interview questions, for you to have a good practice to get some reassurance of what you might see at interview. I will ask you things that you have never done before, and normally I'll teach you. So I'll take a short moment and say, okay, you know this aspect of mechanics. I'm going to teach you a new theory. And with that new theory, I want you to apply it to a problem you've never seen before. And there I'm evaluating how quickly you can absorb information, new information, and apply it. So are you quite able to absorb information rapidly, and are you adaptable to that? And again, I Want to Study Engineering has some of those situations. So let's do one. Let's do one together. Here is an example interview question. All right. It'll start nice and basic, and it'll get a little bit harder as we go forward. That's the kind of questions that I write. So we'll take about 5 minutes to do this. You've got a small cylinder of mass m at rest on top of a mound. The mound can be idealized as a half cylinder of radius r. The cylinder is perturbed from equilibrium and rolls without slipping straight down the side of the mound. Part A, I want you to assume the cylinder can be treated as a point mass and find me an expression for its speed when it's reached position A. And I want that in terms of the angle to the horizontal, theta, as shown in the graph, the radius r, as shown in the graph, and any other relevant parameters you deem appropriate. So let's simulate an interview. I'll be the interviewer and the student in some weird amalgamation. So I've just posited this, and I would say, so take a little moment, have a think, and then talk me through how you might answer this question. The most important thing is whatever goes on in your head comes out of your mouth. I want to hear what you're thinking. I don't want you to worry about saying anything wrong. Everyone says things that are wrong when they're trying to solve a problem. That's a really fundamental part of problem solving. So go for it. And you go, okay, well, I've got a mass M at the top of a mound. Idealized half cylinder is the hill. It's going to roll down, and I've got to find the speed. Okay, so how could I do that? I could do Suvat. Would Suvat work? No, Suvat wouldn't work. What about conservation of energy? Conservation of energy would work because I start with just gravitational potential energy, and as I start to move, I increase kinetic energy. So I could convert, I could assume conservation of energy and see how much gravitational potential energy I've lost, because that'll equal the kinetic energy. So mgh, I start, and h is r, the radius of the hill, and that's going to be converted to some amount of kinetic energy. Kinetic energy is half mv squared, and the v is what I need. I need an expression for v. So that's great. So I do a bit of trigonometry. I can work out the height that the cylinder will be at A based on just basic trigonometry with respect to theta. Yeah, I want to find the opposite side of my triangle, my right angle triangle. So I'm going to do r, which is my hypotenuse here. So I'm trying to find the opposite. So it's sine theta equals opposite over hypotenuse. So it's hypotenuse times sine theta will give me my height. Bish bash bosh, you get a nice expression for v, some rearranging, a bit of algebra, and you'll get there. The next part I might make a bit more complex. I'd say thinking about how forces are acting on that cylinder, the speed that you've just found, and any accelerations, and how they change as the cylinder moves down the surface of the mound. Find me an expression for how the normal contact force, N, varies in terms of the mass, gravity, acceleration due to gravity, and theta, the angle from the horizontal. So I've given you a little bit of a clue in the question. We need to think about forces. We need to think about accelerations. So let's do that first. Forces on a cylinder. We're going to have friction, aren't you, acting in the opposite direction to motion. You're going to have weight, mass times gravity, which will be acting down. And if we've got a force acting down, I'm going to have contact force, a reaction force, N. So that's going to be normal to the surface of the mound. Sorry, I've got a dog invading me. I don't know how you've broken into this house, but I do know you've got it. Oh, there you go. That's a little treat for you. Just got assaulted by a dog. Okay, so we got that contact force N. Now I need to get an expression for the contact force N. Now, what's going to impact N? I know I'm going to have one component of mg, aren't I? I'm going to have a component of mg, and I should probably resolve all my forces perpendicular to the surface, yeah, in the direction of N. If we're at A, my N is in this direction. So I could resolve my forces. So I've got a component of mg sine theta. Sorry, mg cos theta. No, mg sine theta. See, we all make mistakes. Then you would have a centripetal force as well, because we're accelerating towards the center of rotation, and we're also tangentially accelerating as well. Now, you may know the expression for that acceleration, for that centripetal acceleration in terms of speed. If you didn't, I would happily tell you it. It's v squared over r. So v squared over r is that acceleration towards the center. So now I can, with F equals ma, I can convert that to a force, so mv squared over r, and I've got my mg sine theta. Add those all together, bang, 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 and you get an expression for contact force. Give it a go in your own time. If you can't, we've stormed through that, but that's how you do it. That's a be quite a good interview question. I have used it actually in the past, so I will never use it again. But that was an interview question I asked. And then you could go even more complicated than that and say, what if I stopped considering the cylinder a point mass? How would that change things? What would I have to consider? For example, for my value of, for A, value of speed, my expression for velocity, would that change if it were no longer a point mass? Yeah, because I'd have to think about rotational energy. That would take some of the energy. So actually my velocity would be slightly lower. Amazing stuff that you can do with maths. Right. Okay, so that is your lot. We've got a nice Q&A now, and I think we've got Callum with us. I ran over a little bit despite feeling dreadful. Is Callum here?
I don't think so,
Okay.
because I should have had the correct link. So it may have been all the exams are very, very close. They
All
might
right.
be here. So
I'll
we'll try answering them for now.
Let's storm through these. Right. Okay. We've got the Q&A, so you've got a
Yeah.
little thing you can post questions, and I'll start reading these out and having a look. Right. Open versus college application. Is there any advantage to doing an open application, i.e., is there a greater chance of getting in if I do so? No. The admissions process is designed so regardless of what college you applied to, statistically, you should have the same probability of getting in. Okay. So that's the party line on that. Is it?
That
Oh,
was the same question.
oh yeah, you do. Yeah, that's brilliant. If you can do that, that'd be great. Will there be a recording sent after the session? Yes, there will. Bang. Would your accreditation be only from the institute related to your third and fourth year specialization? Principally, yes, they are the accrediting body for that specialization. Now, actually, you can have a degree that's a specialization in mechanical engineering, or you often students can choose because they've done certain modules that allows them to choose aero versus mechanical. Some even specialize are eligible for 3 different specializations. So they're all those degrees, all those accrediting bodies have accredited your degree. So you have multiple accreditations. All right. The truth is, if you want to become a chartered engineer with respect to Mechanical Institute, but you specialised in electrical, um, it doesn't mean that you can never be chartered with the Mechanical Institute. It means you have to sort of clarify a few bits and bobs and you have to do industrial experience in that area, but you can still become a chartered mechanical engineer with a general engineering degree or an aerospace engineering degree and so on and so forth. So don't worry too much about that. God. What is the acceptance rate for engineering at Homerton College? It says you're going to answer this, Joanna.
No, okay. I just
Oh,
pressed
right.
it to record the answer.
Uh,
It will vary year on year. Roughly for the university, there are about 6 applications for every place.
yeah, so engineering, it's about that. It ranges. So actually, we had a boost of about 33%, 33.5% last year in applications. So we're about 10 to 1 for applications per place. And Homerton, we try to align with the university average. So if we have a huge jump in applications, I take more students. It requires some discussions with the admissions tutors. But Homerton used to be 12 students. And then I came in, and the condition of me taking this job was that we double the students, because the more students you have, statistically, the better they do academically. It scares people to do that because you think, oh, well, we're going to have too many, and then we're going to have to accept people that aren't so good. It doesn't happen. It doesn't happen. We've proven that. So there we go. What makes engineering at Cambridge different compared to Oxford, other top universities? Well, I mean, Oxford and Cambridge, again, have that flexible approach. So Oxford and Cambridge share that. You do a broader range of subjects in your first 2 years. Oxford is remarkably, almost suspiciously similar to the Cambridge course. But again, they have slightly different approaches. Their facilities are slightly different. The labs that they do, what they choose to do in their modules is a bit more like what Cambridge did kind of 10 years ago. Cambridge Engineering is going through a complete revision of its educational program at the moment. So by the time you individuals will join, it's 2027, the new structure is going to come in. And there'll be information about that online shortly, but I'm not eligible to tell you about that. But which we try and keep our course as up to date as possible, and we revise that quite frequently. There we go. What about specializing in software engineering? So you can do that. That's part of information engineering. So you can do the hardware, but you can also do the software. So a lot of people really love coding, and that's what they want to do. And they're thinking, oh, do I want to do computer science or want to do engineering? Now, if you love coding, actually, computer science probably isn't really for you. Computer science at Cambridge is very theoretical. You're not becoming a software engineer. You're becoming a computer scientist, more so than that. We don't do a tremendous amount of coding in engineering. You can in your third and fourth year, but if you're desperate for coding, most of our students that want to get that fix in their first, second year join the hackathons. So they do coding in society kind of environments, really. But yeah, you can specialize in that. I want to apply for engineering and mathematics courses. How do I tailor my personal statement to fit both in effectively without being disadvantaged? Or should I make two personal statements? You don't have an option of making two personal statements. You only get one. And we know that. We know that people apply for different courses. And, normally the course you're applying for, yeah, it makes sense what you're applying for. It'd be a bit strange if you're applying for engineering and then history of art. That might make me wonder.
It'd be a
But
good personal statement to read, though, wouldn't it?
yeah, it would, yeah. So no, don't worry about that. Your personal statement is an opportunity for you to sort of, identify in particular your super curricular. What gives you what has inspired you to apply to the courses that you have, and what have you done to affirm that that's what you want to do and further your education. So I like to say, I mean, I have a personal preference in what I like to see in a personal statement, but certainly super curricular and indicating the commitment that you've made to further your understanding is really admirable and what I like to see. And it might shape the kind of interview questions I ask you actually. So no, you won't be disadvantaged. Don't worry. Don't worry about that. Is it more competitive to get into Homerton for engineering? No, like I said, statistically, whichever college you apply to, you should get the same. The system is designed so you should have the same probability of getting a place. Now, in reality, that's not always the case because some colleges have limits in their numbers and so on and so forth. But we have the pool for that. So as long as colleges use the winter pool appropriately and the summer pool, which is where a college might think you're capable of studying engineering or have potential to be a thriving Cambridge student, but they don't have space for you, you get put in a pool. And then other colleges that have spaces come along and they fish in the pool and they find that student looks good, we'll take them. So you might apply to Homerton, but end up at Clare College, for example. Homerton actually has quite good use of the pool. A lot of Homerton students have been taken from the pool in engineering in recent years. I run the pool as well as director of admissions, so I keep a very close eye on Homerton applicants to make sure people are aware of how good the ones that maybe I couldn't quite accommodate are. But I tend to be a bit greedy and I like to take them myself. That's why we've got so many engineers. Good. What are common mistakes that students make in interview that we could avoid? It's terrible, and I shouldn't say it. I probably shouldn't say it, but because you can't help it, so it's not really a mistake. But worrying too much about it. Everyone's nervous. I'm nervous when I'm interviewing you sometimes, and I remember my interview. I was very nervous, and it's totally fine to be nervous. But I've told you what my priority is with you in terms of what I'm looking for when you're being interviewed. I'm not interested in what you wear, whether or not you salute me when I come in or anything like that. I just want you to just approach this like it's another day at school and just show me you've done all the hard work. All your years at school is the hard work. Okay. The interview is just a formality. You just need to sort of reiterate those things that you've learned. Take those methods that you've learned in school and just apply them to the problems that I set you. So I would just say the interview is a formality. Take it in your stride. Don't worry about me or anyone else in the interview. You
Fun
just
with it.
give it your best shot. Yeah, give it your best shot. So there's not really any mistakes that people make. Um, just yeah, have fun with it. Tell me what you're thinking. That's the key thing. Blah. How can applicants stand out in personal statements, interviews? What do you look for? Well, again, academic um, achievement is the principal thing that I'm interested in. I'm not really interested if you're a world-class cricketer, I'm going to be honest. It's admirable in terms of if you've managed to do that and you've had such academic attainment, brilliant. You know, it shows that actually you're very good at time management, which is very important when you come to university. You've got to do time management. Some colleges will say, I don't give a flying monkeys about your extracurricular, but it is something to consider. But not all of us can do it. So I'm not going to disadvantage someone if, you know, they've not been able to go and play cricket around the world or anything like that. I didn't get the opportunity to do that. I was too busy because I had to earn money. Um, so no, I mean, a personal statement is just be yourself and be honest, because I can tell you if you're not honest, we will know. And that is really going to damage your application. So you just be honest, tell us who you are and why you want to study and what you've achieved. Do you have a Formula student team? Yeah, that's the Formula One student thing that I referred to earlier. Homerton is a huge part of that. I've just signed off about 5 applications for them to go and compete. And I couldn't believe that 5 of them, there's only about 12 in the team, I think. So, hey ho, there you go. That's the way it is at engineering. If you go in the engineering department, you say Homerton, they go, oh, they won it again. Okay.
You've got another couple miles about that. Who runs the Formula student team and how to
Uh,
get involved?
Okay, so you can come to the open day in July and the Formula student team will be there. And normally they set up a little car. Me calling it a little car they'd go ballistic with a little simulator, and you can have a little drive. You can see the garage where it's built. There's a bespoke garage round the side of the engineering department where all the welding and whatnot take place. It's run by the students. It is a student entirely led process. Academics poke their head round the corner and just give them a bit of guidance now and again, as is inevitably needed. But it is solely, really, a student led program. So you design it, you build it, and you race it. Okay. How important is work experience in my application? Uh, some of us have the opportunity to do work experience. If you do, put it in there. It shows that you've given due consideration to why you're doing engineering. You've got a bit of experience. Say, you know what, I quite enjoyed it. It's made me think that that might be what I want to do. So it gives me a bit more reassurance that you've given due consideration to you choosing engineering. But it's not essential. Some of us, like I said, don't have the opportunity to do work experience. We're too busy doing other things, and that's fine. So, not really that important, but you know, it can help. Good. Is there any difference in the value between virtual and in-person work experience?
Just depends
Um,
what you've been able to access, really, doesn't it?
yeah. Again, some of us can do in person, some of us can do virtual, and it depends on what you're doing, really. I mean, that's the most important thing is the content of your placement, of your experience that you're doing. As long as it sort of shapes, you know, it gives you a bit of excitement, you enjoy it, and you've got a bit of sort of beneficial experience, or you're being able to apply some of your skills and show that, then doesn't matter if it's in person or virtual. And quite frankly, even if you absolutely couldn't stand it, it's still beneficial because at least then you know I never want to go and work for that company. Or it may be you never want to go and work in that specialization because, it was dreadful. And that's worthwhile equally. You learn more from your mistakes or things you don't like, from my experience at least, or maybe I make more mistakes, than you do your successes. So there you go. How moving. What are current famous research projects that Homerton College have done? Oh, ones that I want to tell you about. Um, God, we've had all kinds of things. We've had quite a few. I mean, there's been quite an appetite for AI developed sort of hardware or AI assisted hardware. So quite a few computational things. But we've also had people working on um, thrusters for jets, so new type of three-axis thrusters that you see Russian fighter jets use. The Americans and the British, well, the non-Russians um, tend not to use that. But we're going into an arena there. But we had a student look at those. Um, we've had a student design a new type of nuclear reactor, came into the project at a perfect time, and chances are that reactor will be tested, which is incredibly rare. Even in, I've designed reactors that probably won't ever be built in my time in my lifetime, but maybe in the future, or they'll be built in about 40 years when no one will care what I have to say because I'll be too old and out of date. Um, so there's plenty of different research projects that I could kind of discuss, but they're so varied. Uh, how much an advantage is it to be chartered? Some jobs require chartership. They won't accept anyone to apply that isn't chartered. It gives you access to particular benefits, but it is principally it's like it's a qualification, really, like a degree in order to get a job in engineering. Your chartership says, I'm a proper engineer now. I'm not just a graduate. I've got the 1,000 yard stare. I know the drill. So you get those better jobs as a result. So it's quite an advantage. If my school does not offer A-level further maths and I do not do it, can I still apply to Cambridge? Well, if it doesn't offer and so you don't do it, you won't be disadvantaged at all because if you're not given the opportunity to do it, then it would be unfair if we disadvantaged you as a result. And there's an opportunity for you to say as much on your application. So there's a thing called the My Cambridge application. I always forget which one is the out of date one, if it's the UPQ or whatever. I can't remember what it's called, but it's called My Cambridge Application. And in there, you can say, is there any modules that you wanted to do that you weren't able to do? And you say further maths and give a reason why. And your school signs that off. So your school will say, yes, we couldn't offer further maths because of scheduling issues, or we just don't do it, for example. But like I said, I strongly encourage you to do as much maths as possible. So you can independently learn further maths using the, it's escaped my head now. Do you remember what it's called, Joe? AMF, Advanced Maths Program, online, further maths modules. You can learn that yourself. It'll help you certainly with the, even though further maths content isn't examined in the ESAT, it will help you because more experience in maths will just make you a better mathematician. How is the balance between theoretical learning and practical based work? Well, I would say that it's perfect. Yes, Cambridge, there is a huge volume of theoretical knowledge that you need to do well, but you need the practical skills. So you saw the breakdown, this sort of typical timetable for a student. There we go. So you can see that on this, it's almost 50-50. In fact, for first years, it effectively is 50-50 practical and theoretical if you ignore self-study. So we understand that engineers, have a thirst for the practical aspects, and so we want to enable that, and it's quite an important aspect in prospective employers to look for in prospective employees. Right. How far is Homerton from the engineering department? Remarkably close. You can cycle that in 10 minutes. Depends on how fast you are at cycling. I think walking, I do it in about 20 minutes. But yeah,
I think 10 is probably being quite generous cycling as well. I think you could do it quicker than that.
I'm a bit lethargic. Uh, yeah, I mean, I've had students race back. I think the fastest is 6 minutes. Someone came back in 6 minutes. And that was for a supervision. So normally they like to go nice and slow. Then get back in 6 minutes, fine. There are other colleges that are further away, but there are colleges that are closer. But we're in Cambridge here. Everywhere is close. Okay. If you go to like Manchester University, your halls of residence are quite a lengthy bus ride from where your lectures are taking place. For example, Cambridge, everything is cycling distance away. All right. And most people cycle. So when you start here, normally we give you some guidance on how to get a bike and maybe even how to cycle. I've run a cycling test for another college when I was senior tutor there, and that was great fun. Anxiety inducing, but for me, but great fun for the students. Um, Right. I'm interested in the general aspect of the Cambridge engineering course. Most of my supercurricular investigations have been into one specialization, though, which I'm currently intending, hopefully, to specialize in. Will I be at a disadvantage in my personal statement if I focus on one field or specifically? No, no. I mean, I'm envious that you are sure that you want to focus in that specialization. That's brilliant that you've experienced something and that's what you want to do. So talk about it. But again, if you're not in that situation, you're not quite sure what you want to do, that's perfectly fine. You talk about why engineering more broadly do you want to do it in. So no, you're not at any disadvantage for saying unequivocally, I want to do information engineering, for example, control engineering. No, no, no. Talk about it. That's what I want to see. I want to see you have given due consideration. How many engineering students are there per year at Homerton, and how many people apply on average? Well, at Homerton, we normally get 20 to 25 students per year. That's our target. And normally applications from year to year, they range, but you're looking at 160 to, I can't remember what the maximum we've ever had is, 200. I think it was. I think that was the record. It's normally Trinity and Homerton have the record number, and we have the most students. So there you go. So yeah, 10 to 1, pretty much. Tends to be the way. Do you have ideas of projects, research that a 12-year-old, oh, sorry, a year 12-year-old, a year 12 could do to show on your personal statement, designing something, modeling something? There's this expectation that you need to have read A Universe in a Nutshell and these kind of, I'm going to be honest with you. I reckon about less than 1% of people that own Stephen Hawking's A Universe in a Nutshell have read it. It just sits on the coffee table. It's probably the most dust-ridden book on earth, that one. And I've read personal statements to say I read this and this is why I want to be a physicist because I used to be a natural sciences doc. No, you don't need anything like that. You don't have to read books. It can be that you just watch YouTube videos about things, or you've just, something as basic as you've chosen to take something apart and look how it works. It could be as simple as a kettle. I mean, please make sure it's unplugged when you're taking it apart. But that's the sort of thing that we do with students is we look at product design and we strip apart a very basic hairdryer, for example, and then you can look at how it's built. And actually, it's remarkably complex in the decisions that you need to make, for example, with material selection. Um, so the possibilities really are endless. You could be a magazine. I just think you need to sort of have your sort of finger on the pulse of engineering, see what's new that's coming out, what sparks your interest, and read about that. And if you want to have a crack at it, then have a crack and build something or read further on it. I don't have any expectations with, I don't want someone to say, I built a car, innovatively made of hemp. Or, it really doesn't, it's not going to make a
Cool, but
yeah, it fell apart because the wind blew. Uh, there's all kinds of things you can do. Just do something that interests you. You're never going to do well at something that doesn't interest you. So find something that interests you and stick to that. That's what I would suggest. Is there much of a difference in the education you get depending on which college you attend? No, like I said, the lectures, the labs, all of that's hosted in the central department. The colleges can have quite an impact on your educational program, I'll be honest, principally in your sort of super curricular and the kind of work ethic and approaches to work that they instill. So that's why I'm very proud of Homerton, is that I think we have quite a unique and wholesome approach to learning. We're a very close-knit community, and I instill in the students my expectations. I'm very clear with my expectations of the students and the expectations they should have of one another. And so I think well, statistically, it's very clear evidence that having a larger community of peer-to-peer support helps you in your education at university. Um, and Homerton has that. Other colleges, you may be one of only two or three engineers. Um, there might be provisions that a college has that others don't. Might be study skills. Some might have a workshop. So rather than going to the Dyson Centre, which is quite an impressive build whatever you want center in the engineering department, you don't need to leave. You can just do it in the college. Uh, it's never going to compare to the Dyson Centre, but it can be quite useful when your bike breaks and you can't be bothered to walk to the department, and you can just fix it in the college. So yeah, colleges vary, and the best thing to do is have a look at some and see which seems to gel with you, because
That's important.
colleges work for one person, they might not work for another.
Miles, can I just interrupt? We've got some repetitive or repeated questions that you've answered already. So I
Okay.
just want to say before I'm going to type in just already answered so that we know where we're at. Please, if it's your question and I'm typing that, don't think I'm rude. It's just that we've already answered it and we want to finish so that everyone can hear all the answers.
Okay. Blah, blah, blah. How are students assessed? Is it exams, coursework? It's all of that, all of the above. So you get exams, that's your principal way of assessment. But in engineering, you get coursework. You get something called standard credit. You turn up to the labs, you do the reasonable amount of work, you submit it, you get standard credit, 100%, basically. And that's a whole module. So that's one module out of 4 papers. So it basically acts as you get a paper, and that contributes to your final mark for your first year. It differs from year to year, and it depends on what modules you do in your third and fourth year, for example, because some will be assessed by coursework in part and also in exams. Blah, blah, blah. First 2 years being general to get a taste of everything, but I want to know if I were to compare this degree to one where we study electrical engineering for 4 years at another university, would the depth of knowledge in that field be lower since we have 2 less years of specialization? Well, it depends on what course you're talking about and what institution you're talking about, because engineering degrees vary vastly at different institutions. And I can tell you firsthand experience from being I spent a year at Imperial, for example, doing nuclear there, because in those days Cambridge didn't do nuclear, so I left and did a master's in Imperial, and it's a very different place. We have lecturers that have come from all over the place. I teach a master's course where I have students that are very rarely from Cambridge. They're normally from abroad, but I often get universities in the UK. And no, sometimes their understanding in certain areas is less than that of Cambridge. Cambridge, the contact hours, the amount of work that you learn can often be equivalent to some degrees that specialize from the get-go, because a lot of the fundamentals are very, very similar across. If you specialize in electrical, you're going to do the fundamentals in maths that you have to do for mechanical, for example. There's a lot of crossover there, because engineers are fundamentally interdisciplinary, or multidisciplinary, rather. Um, so yeah, there can be that you have a little bit more, but it doesn't impact your recruitability. It doesn't, or employability. Doesn't seem to impact that. Cambridge is notorious for producing engineers that are highly capable and multidisciplinary. So they're very adaptable and highly prized. So I really wouldn't worry if that's your concern. During the interview, do you get a pen and paper or do you have to do it all in your head? No, you don't have to do it in your head. I would strongly recommend that you use pen and paper. Different people have different approaches to learning. I like to have a pen and paper. So I would say, have you got a pen and paper handy? You'll get all this information before the interview. We give you lots of information, so nothing is unexpected. But yes, you get a pen and paper. During an interview, would you be expected to do, oh, you've done that. Why
Okay.
do you get 2 degrees? And is the only available, and is this only available? Yeah. I mean, the BA is kind of honorary thing. It's not really, you're not really got a second degree. It's an antiquated process of Cambridge where in engineering you used to graduate with a Bachelor of Arts before the accreditation of the MEng came in. So you graduate with a BA and you get an MEng. And also you also get a third degree in a few years afterwards when you come back for an MA, which is again a Cambridge thing. So you end up, if you do engineering, you leave with 3 degrees after 5 years. Um, they're not proper sort of, it's not a proper BA, not a proper MA. And people will know that when you say, oh, I'm from Cambridge, I've got 3 degrees. They go, oh, so really it's just one. So it's just, but there's Cambridge is full of all these bizarre things that are Cambridgey, and you'll get to grips with it. Don't worry. With that list of modules for years 3 and 4, did the colors have any particular significance? Yes, they are split into specializations. Where are we? We'll zoom through this so people know what I'm talking about. Yeah, so you can see that they're different letters here. That differentiates the different like groups, different sectors. So you've got the aero, you've got the information groups. They're specialization groups. We got different divisions. So if we zoom back to D, they're the divisions basically. Not necessarily because I'm in the energy division, and the energy division offers particular modules. So you zoom over to the modules, and you can find some energy modules which are on nuclear and so on and so forth. So yes, so here you go. So here's some business economics and business of engineering. You can look at there, and they're the sort of brown color over there, 4E3, 3E1, for example. All right, red ones being some of the more rogue ones, for example, nuclear power engineering. These are more broad, these are mechanical, but they're broad mechanicals. So software engineering, electrical environment, they tend to be the energy ones. Okay, so plow through. Is the timetable drastically different in years 3 and 4? Not really. You have just as many lectures and labs. It's just there's a bit more variety in what you're doing because you get a choice of what you want to do. But no, the contact hours are very, very similar. Right. I didn't see materials engineering as one of the specialisms. Is that something? If that was something that I was interested in, what do you suggest I apply for? Well, you can do material science. You can apply for natural sciences and do material science if you want to be a material scientist or a metallurgist. But we do materials. You're obligated to do materials in first and second year. That's something that I teach, and I lecture that to fourth years as well. Nuclear materials, so radioactive materials and nuclear fuels, how to design nuclear fuels. Materials is a possible specialization in your third and fourth year. You can go into that. So you can go to biomaterials. If you look at the pink ones there, you can go to bio. If you look at the green and top left, the 3C1 and so on, that's the materials group, materials processing and design, dynamics, vibration, mechanics of solids, soil mechanics is a bit of materials, mainly civil though. Machine design, looking at bearings, for example, fraction mechanics, why things break. They're all materials. So yeah, you can absolutely specialize in materials. You graduate as mechanical engineer, typically, if you do those. If you apply to Cambridge in 2027 rather than 2026, does that mean you have to redo the admissions test? Or can you only do it once during this October? Oh, right. So if you apply for deferred entry, no, you can use your you can use your ESAT score and apply for deferred entry to start later. That's fine. You don't need to redo that. Now, it doesn't necessarily, you can apply in a year's time, and then you would have to do the ESAT in a year's time. But no, you can apply for deferred entry should you wish and do the ESAT this October. What would you say the most important part in the application process would be? I mean, they're all, we look at people holistically. We look at an application holistically. We look at all the different consideration and aspects and how an individual may have their own personal weighting or ability in one thing, but not the other. And we have to take that into consideration. So we're as fair as possible in assessing the academic capability of a student. So I wouldn't say there's anything particularly weighted. From experience, students put far too much weight on the personal statement. They spend too long worrying about that. It's not so important. Doing well in the ESAT is obviously very important because it tends to be the thing that links to whether or not you get interviewed. But obviously, you've got to get the right grades. So the only thing I can really say is slightly less important is the personal statement, really. If you aren't sure if you want to do chemical engineering or engineering, can you swap courses after starting? My approach, my ideal answer to that is no, but the real answer is yes. So you can apply to change tripos. Now, you really have to have exceptional justification of that, and it has to be in the first couple of weeks, really. I would say in the first week. I would really not recommend anyone switching tripos beyond that because you've already fallen behind. You've only got 8 weeks, nor is a typical term at Cambridge, and it is jam-packed. There is no fire break. So you coming in week 3, you will struggle. So you're not going to learn very much about whether or not you want to be an engineer or a chemical engineer in the first week. So you need to do some investigation into the courses, go online, look at some videos, and have a little think about, careers and what might be better suited to you. What does that mean, knowing how to code isn't important for applying for engineering? No, you don't need to know any coding to apply for engineering. Absolutely not. One of the most common things that students say is, I wish I knew a bit of coding when they started. Python. Python for beginners or Python for dummies. There's loads of YouTube videos about the basics of Python. That'll help you when you start on the course because you do a bit of Python coding, but you don't need to have done any whatsoever before you start. Okay, we teach you how to do it. It'll just make it easier for you if you get a head start. Do I only need physics and maths A level for engineering? They are the requirements that we have is maths, physics, and then another STEM subject, which most commonly is further maths, and the majority of our successful applicants have studied further maths. But we have people do chemistry as well, biology, history, we have all kinds, but the requirements are that you do maths and physics and one other STEM subject. Is it a 3-year course or a 4-year? It's a 4-year course, but you can leave after 3 years. Most people stay for 4. You have the option to leave, and the requirement there is an academic requirement for you to go on to 4th year, and that's that you get a 2-2 in your 2nd or 3rd year, which is 50%. So I wouldn't recruit you to Homerton if I didn't think you were capable of getting that. So I've never had a student not be allowed to progress to 4th year. And you need a 4th year to become chartered. If you leave off 3 years, you've got to go and do some night school in order to get your chartership. In the interview, would you be given a formula booklet? No. And I will never expect you to be able to just, I don't care if you can memorize an equation or not. That's why I said, do you know the expression for this? And if you say no, I'm not going to discredit you for it. I'm just going to tell you it. So no, I'm not really interested in you learning equations off by heart because the probability of you being in a job where you have to just know an equation off by heart because you have no access to the internet is remarkably low. And I worked on nuclear submarines where you don't have the internet and you don't have a mobile phone. And fortunately, I could remember some things, but I was allowed to take textbooks with me. So even on a nuclear submarine, you're allowed to take things with you. If you have done some extracurricular activities, is it better to mention them in the personal statement or to put as much academic information? Prioritize evidencing your academic ability. and academic achievement over extracurricular activities. You should more focus on supercurricular. So that could be you shifting extracurricular to be supercurricular. I was in a I was in a production of Chicago. This is not me. I was never in a production of Chicago. I'm just making something up. I was in a production of Chicago. Uh, that taught me about the processing of lighting and production in terms of synchronizing audio and lights using blah blah blah, blah. So I've twisted a production of Chicago that seems very arts into an engineering thing. I play cricket regularly. It's helped me with my time management, but it's also got me thinking about the sort of physics, or rather the fraction mechanics and mechanical properties of willow in comparison to other bats. When I brought my bat made of oak, it smashed to pieces, whereas my willow bat was remarkably bouncy and I got lots of sixes. See, so you can twist things. So your extracurricular, try and make supercurricular would be the best advice I give you. What do you mean by academic enrichment? Well, furthering your academic experience. So anything that helps further your knowledge or experience in the academic content that you're learning at school is academic enrichment, really. Do you offer summer work experience? Me personally, I can't take you on the submarine. And no, no, I don't offer summer experience, and the department doesn't either. We don't really do that. You can get your school to book in for an event. We do various bits and bobs, so you can come and experience the department and do, you know, a day or 2 days or so on something. But we don't offer general work experience. We used to, but we don't do that anymore. It's too complicated with safeguarding and everything. Is it worth taking a gap year to prepare further if rejected after the first time applying?
I,
Yeah, go on.
I was just going to say that there are many, many great courses that you could apply for, and you have to weigh up whether actually going off and studying somewhere else would be the right thing for you. And often, if you've got an offer somewhere else, we would probably encourage you to take that up and move on and be a great engineer. Miles, if you disagree, that's fine. That would be my
No,
kind of answer.
no, no, no. You know, that it's a public. Britain has an obsession with Cambridge and Oxford, okay, and there's this perception that it's the be all and end all, and that's fueled by schools and often parents as well, unfortunately. Now, you know, there are other universities that are remarkably good, and you get a wonderful, if not better, qualification from them. You get a great experience, and some universities are better suited to
Mm.
certain students than Cambridge is. Cambridge isn't suited to everyone. That's the way it is, and you've got to have a look and see if you like the look of Cambridge and it appeals to you. Gap years, you know, I would encourage a gap year if you do something useful on a gap year. So if you go and experience something in engineering, you know, you get a better understanding of what it means to be an engineer. You go and do some work experience. I would say go and do that. Gives you a good experience often helps your work ethic a little bit because often you have to work 9 to 5, which is nice experience to get you ready for university. And it reassures or reaffirms your belief that engineering is the right thing for you. So I'd say if you were rejected, I would say you've decided to go to university. I probably would go to university. I wouldn't reapply, but you are perfectly entitled to reapply should you wish. Uh, in the first 2 years, what is usually done in lab practical sessions? Are students seeing a practical example done by a professor or building things themselves? You're doing it yourself. So you're doing a test yourself, you're taking the data, and the main thing, you've got to analyze that data and come to the conclusions yourself. I don't want you to just be a robot that just kind of follows orders and does what I do. I want you to indicate independent thought. I want you to develop the ability to solve problems independently yourself. Otherwise, you're not going to be a very good engineer. You're just going to be a sheep. So we expect you to do the stuff yourself. So yeah, practicals are students in groups of two doing a lab. So it might be doing measurements with a as basic as a voltmeter, or it might be as complicated as you doing a mechanical test under cryogenic conditions and looking at how a material might be impacted by changes in temperature in terms of how much energy it could take before it smashes or fractures. And then we could say, that's what happened on the Titanic. That's why the Titanic sank so quickly. Or that's why a particular space flight blew up because they took off at too cold a temperature. You get all of this, you'll learn about. In the first 2 years, what is usually done in labs
Oh,
practicals? Oh, we've done that
sorry, gone
already.
on.
I have an EPQ about Formula One and it's engineering. Would this be an advantage in my application? Yeah, I would talk about it. I'll talk about it. EPQ is a good opportunity for you to get a bit more experience of engineering and actually do something a bit more conceptual rather than more kind of curriculi based work. So talk about it and we can ask you questions about that. I can engineer some um, kind of quantitative questions to test you on in the interview because you're probably going to do better at something you're interested in. Are attending lectures mandatory? It's a shame that that's an anonymous attendee asking that. No, they aren't mandatory, as in there's not, you're not going to be kind of
Registered,
registered. We do
but they
register
are
numbers.
strongly
Yeah.
advised.
We do register numbers, but we don't register individuals. But there is a very clear correlation, and it is a graph I show you during your bridging program of attendance to lectures and achievement in at the end of the year or classification. And there is a very clear correlation. And the same is with attendance supervision. Now, supervision attendance is mandatory.
Mm.
And there will be repercussions if you do not attend because they are so important to your educational program. You got to understand that my priority is you doing well. You know, I talked about being competitive. I want you to do well because I want you to excel as an engineer, but I want us to do well as well because you doing well is me doing well. Okay, so you just got to take my advice and go to lectures.
Go.
Do you take a language module? Yes.
You
You
do you
don't have
have
to.
to?
You don't have to. No, you don't have to do that. You students take it in their second year. They can do a bit of language, but you don't need to take it any further than that. And it's small lessons. It's not. Students always enjoy it. It's never a problem. If I applied to mechanical engineering, will the selection be made specifically among other mechanical engineering? No, it won't. Or will I be competing with students from all engineering programs? We're a general engineering program, so I select students who, regardless of what their specialization is, it may be that every single student I pick just so happens to end up as an electrical engineer. It doesn't matter to me. I don't try and split students up and say, oh well, we should take a few mechanical engineers. It doesn't come into consideration. I pick the best students who are going to thrive at Cambridge
Uh,
regardless of specialism.
Miles, we're going to have to finish in about 3 minutes.
Okay,
We've
let's
got
look for
five questions to go, but two of them are about 3 versus 4 A levels.
Okay, is there much advantage to having A level 4/3? Now you'll get conflicting answers in this, and so I'm going to give you a personal answer, and that is in that is my opinion, not the opinion of the department nor the college. Um, there are benefits of doing four in terms of it shows evidence that you can withstand a heavier workload, which is good experience for coming to Cambridge. But the priority unequivocally should be that you do well in the modules that you are doing. So if there is a risk that you will not meet the entry requirements of doing three, or you will do less well in three, should you take four, then you should do three, if that makes sense. So if you're running the risk of losing those two A stars by doing four, and you're worried about that, then I wouldn't do it. It's very hard to know what the right answer is there, but we have a large number of students, significant number that are successful that have done four A levels. And yes, it does show ability to take a larger workload. However, if you weren't able to do four, you will not be disadvantaged.
Mm.
And which four you do, it varies quite significantly in the significance of it because there is a lot of correlation between maths, further maths, and physics, even maths and physics. But maths and further maths, you're doing similar modules, aren't you? You're putting together your further maths with the modules that you could also put into your original pure maths at A level. So normally, if you're doing maths, further maths, and physics, A fourth A level is far more common because actually that correlates a little bit more to a diverse workload of students that are doing very different A levels.
Mm.
All right. So in engineering and natural sciences, it's a lot more common for people to do four.
Yeah.
Yeah.
There's also just for anyone looking at entry requirements, I've put it up as a link in answer to some of these questions. But if you Google or search on the internet, engineering Cambridge, you'll be able to find the apply page, which has entry requirements on it.
Yeah. A star in maths, A star in physics. So it's A star, A
Yeah.
star.
It just talks about the other subjects as well, so it's quite handy.
Okay. Do you recommend to do master straight after the degree? There's no point in answering that now. You will see. So if you're doing engineering, then you're going to get a master's anyway because you're doing your fourth year program. Um, you'll see where you are, and as a DOS, I'm the person that would give you some guidance on that. I tend to strongly recommend because often I get that question, but it's PhD. Should I do a PhD? I For people that seem really sure that they want to be an academic or researcher, I would even say go away for 2 years, work in industry for 2 years, get a good experience of exactly what your options are, because industry is very different to academia. Okay, is engineering as a career one of continuous learning? After you finish your course, you constantly keep learning, adapting your skills to changing in the industry. Yeah, it never stays the same. Never stays the same. You design one thing, and within about 5 years, you've got to design the successor to it, and there's new challenges. So, people talk about AI being like the new printing press. It's going to transform everything, like they said about the internet, and the internet did have a significant impact. The world evolves and you've got to keep up with it. And as an engineer, you're the one that evolves that world because you're the one that designs the internet, designs the printing press, and develops AI. So, yeah,
But that's
absolutely.
what makes it fun.
Yeah, you're the one that is kind of pioneering that. And that's why you want to be an engineer, really. I am doing physics, maths, and biology. Will I be at disadvantage for not doing further maths? If you could have done further maths and you've not done further maths, then that could be considered a an indicator that your maths may not be as competent as others, um, because you have chosen not to do maths. That would be taken into account. However, if it's because you have a real passion for biology and you want to continue doing that, then say so in your application, and then we'll take that into consideration. So you shouldn't be disadvantaged. But
Give us the
like I
context.
said, yeah, but like I said, get as much maths experience as possible, and it'll prove your capability in the ESAT. So that's a key indicator of your ability, your academic ability in mathematics, is the ESAT. So no, you got to consider it in the context of what you're doing and why. So there's not an easy answer for that, um, but not necessarily. Right. Okay. Crikey.
Brilliant. Well, Miles, thank you so much. That was, especially for someone who's not feeling 100%, a brilliant tour of engineering. Um, if there are any questions that people still feel they have or that we haven't been able to answer or we didn't quite interpret as you meant and things like that, you can always get in touch with the admissions office, admissions at homerton.cam.ac.uk, and they will be able to either answer directly or pass those questions along if need be. It would be lovely if some of you are able to visit for the open days. If not, and you'd like to see the college, if you search on the Homerton College website for visits or open days, you'll be able to find that you can book other visits in as well, because there are mocks and things like that for some people. And I think, Miles, we will finish there then. Anything else you want to say? Bye-bye. Thank
No,
you.
yeah, thanks very much for coming and good luck with your application should you choose Cambridge, and I hope you choose Homerton because I can honestly say it's a wonderful place to be an engineer, and come and visit and talk to some of the engineers, and they'll say as much. You're well looked after here. Cheerio.
Brilliant. Thank you so much, everybody.